Let's see another problem, Sudoku solver from LeetCode. In this problem, we have given 9 by 9 matrix and we need to find out if we can solve this Sudoku or not. So how will you know if we can solve the Sudoku? So we have to, when we fill that value in each row, we have to check that the value is unique in each row and again each column and in this box. So in this 9 by 9 matrix, we have the 9 rows, 9 columns, and then 9 box here. So if I put the 2 or if I put the 7 here, then 7 already exists in this row. So then we can say, no, we cannot put the 7. So we have to try all the numbers, and at the end, we need to check whether it is possible to fill this Sudoku or not. So in the same way, we need to also check the, like if I can put 8 here, but the 8 is already here in this box. So that this also we cannot put the 8 here also. So we need to try all this 1 to 9, the value, and try to see if we can fill this Sudoku or not. So in the previous example, we checked whether this is a valid Sudoku or not. So in a valid Sudoku, there were some number givens, and we check in each row and each column and each box. We check that, and if there was a duplicate value, then we say that okay, invalid Sudoku. But this time we have to actually fill that. So in the previous problem, the way we solved is we created a map for each row. So there will be 9 map for each row. So we'll create the array of map for this 9 rows. We'll also create the array of this column. So 9 columns. So array of map of 9 columns, and also we create the array of this box, 9 boxes. And then there is a dedicated map for this row, dedicated map for this row, and all this. Yes, we can create the 9 variables also, but I create the array, so it will be easy. So in that map, we we get each value, we traverse each cell here, and then get each value and put that in a respective map here. And if you find any duplicate value, we return false. And if we find the unique, that's good. So that's we put for the row and the column map, but there was a challenge for this box. There was a dedicated map for this box, again another map for this box. But how to know this is the first box, this is second box, third box? So there was a formula for that, and the formula was uh, here. The formula was something like I divided by 3 and into 3 plus j divided by 3. That was the formula. We can see in a previous I mean other videos. You can just search Sudoku and you can find my video and you can find that. And in this problem, so in the previous problem we wanted to find the location of this box, but this time when we traverse and we come here, then like let's say here that's empty and we want to fill the value, then we can check entire row, entire column. That's easy. But we want to know whether this is under this box or not. So how to check? So there is a similar formula I added here. Exactly, it's a something with array, and we have the I and j. Then what we did, I divided by 3, and also here j divided by 3 exactly into 3 and into 3. And here also I did into 3, and then plus, instead of j, here I put x divided by 3, and here also I put so, so into 3 and then plus x modulo operator 3. So here divide by 3 and here modulo operator, and x is again when we iterate this one like 0 to 8 index, so that is just an index, so we'll see that. So that's the formula. I'm going to use that. So let's see, the logic is not very difficult. So first thing is, I need to have one auxiliary function. So like let's say I have create a function like similar. Just copy this and I say that fill Sudoku, and this is going to return Boolean, and I call this function here board. Okay, so now I have to iterate each cell, and I need to find out like which is empty, or there is a which have dot. And when I find a dot, then I will check 1 to 9. I'll have one iteration 1 to 9. I'll try to put 1 here and see if it is unique in this row, unique in this column, unique in this box. If it is unique, then I will put it there. If not, then again I will try other number, and then again I'll do the recursive call. So let me have one loop here for the row less than 9, 5 plus plus, and again for j another loop, so it's a for j less than 9, j plus plus. Okay, now we'll check. Now in this way we can easily iterate through each cell. Now we'll check if the cell has dot there or not. So if I check if board ij equal to dot, and if it has dot, then that's a good thing, it's a dot. Now we need to try. We try the value from 1 to 9, and we need to check if it's a unique in this row, unique in this column, unique this box or not. So for that I can have one for loop I1, and I have already used, so I can just say k1 and k less than equal to 9, and k plus plus. Okay, here, and now we'll check this one. If I can put one, will that be unique throughout this row, column, and the box or not? So for that I can have one function, like I can just say can be placed, and I can pass this board, I can pass ij location, and then I can pass this k. Okay, I'll write the function here in a few minutes. So I'll check the condition if can be placed. So if this k can be placed on that particular location or not, and we pass the ij also. So if I can able to place that value over there, then in that case let's put that value. So board ij, and I can put by k. I can put the value. Okay, and once I successfully put the value, then I need to check for another one, and for that I call recursively this function. So for that I call this if, and then board, and if it is successful, like if it call fill Sudoku again, go again deeper and deeper and try for all the cells. If there is no false, it's returned true, then I can say return true here. At the end also I'm considering if return true. Otherwise, if if it return false somewhere, then we can do the backtracking, and I can just put it back the previous value, that is dot here. That's good. And this one, if the board I is a dot, then we have the for loop, and if in a good scenario it can return the true. If it is not, then I can just say here return false. Okay, let's develop this function. So I'll just copy this and put it here. It's going to return the boolean, and this is board, type is two-dimensional array, byte, ij both type is int, so I can put int, and this k is type of k is byte, just say the byte. Now we have the board, we have the location, and we have the k. We need to check whether I can put the k in this location or not. So for that I need to have one loop 1 to 9. So let's have this x is equal to 0, not 1 to 9, but 0 to 8 index base, and x less than 9 and x plus plus. It's good. And then now when we come here, like let's say in this row, so I want to fix the row but change the column. So board and fix the row. So whatever the row address we have put here, so it's a fix that, and then change the column, different columns. So then I can put x, and here I check if this board ix equal to k, then return false. That means I cannot place that. At the end I can return true. So I check for the row. Now I'll check for the column. So let me copy this. And in order to check for the column, so check for the column will be fixed, and then row will be changing. So the row will be changing. So that is the x 0 to 9 row will be changing and the column will be fixed. And in that case also I can return false. Also another thing, we need to check the box. So for that box, you can just say I and j, and we can have the formula I divided by 3, j divided by 3, and then into 3, and here also into 3 plus x divided by 3, and here x modulo operator 3. So that's all. Let's run this, check for any syntax error, accept it, submit. Yeah, that's all. So let's see the whole code once again. And we can see the Java solution also. So Java solution is also similar. So we have the loop. If you find the dot, try from 1 to 9, can check can be placed. We'll place the value, run the recursion, return true. Otherwise, backtrack, we can do no valid number found, return false. And here is a can be placed function. So that's all for now. Thank you.